A brief history of time. Stephen Hawking. Imagine the universe as a grand stage, vast and mysterious, where time and space dance together in a cosmic play. Stephen Hawking invites us to understand how this stage came to be, how it works, and where it might lead. It begins with a question as old as humanity itself. Where did the universe come from? For centuries, people believed it had always existed, eternal and unchanging. But with Einstein's theory of relativity, everything shifted. Space and time were no longer separate. They were woven into one fabric, curved and shaped by gravity. Massive objects like stars bend this fabric, and light itself follows those curves. Suddenly, the universe was no longer static. It was dynamic, expanding, evolving. Hawking explains how this expansion implies a beginning, a singularity, where all matter, energy, space, and time were once compressed into an infinitely small point. This is what we now call the Big Bang. But what existed before that moment? According to Hawking, the question may not even make sense, because time itself began at the Big Bang. Asking what came before time is like asking what's north of the North Pole. The story continues with black holes, those regions of space where gravity is so intense that not even light can escape. Hawking's great contribution was discovering that black holes aren't entirely black. They emit a faint glow, now called Hawking radiation, suggesting that even these cosmic monsters eventually evaporate. This insight connects the physics of the very large, general relativity, with the physics of the very small, quantum mechanics. From there, Hawking explores the quest for a theory of everything, a single framework uniting gravity, quantum theory, and all fundamental forces of nature. Physicists hope such a theory would describe every event in the universe, from the birth of galaxies to the movement of particles smaller than atoms. But so far, the equations refuse to fit neatly together. Hawking also confronts the ultimate mystery, the arrow of time. Why does time move forward and not backward? Why can we remember the past but not the future? The answer, he explains, lies in entropy, the measure of disorder. The universe began in a highly ordered state and is moving toward increasing chaos. That's why time flows as it does, toward disorder, decay, and transformation. Yet amid these vast ideas, Hawking's message is deeply human. He reminds us that science is not just about equations, it's about curiosity, imagination, and the courage to ask questions that may never be fully answered. We are, he says, just an advanced breed of primates on a small planet orbiting an average star, yet capable of understanding the very laws that govern the cosmos. In the end, A Brief History of Time is more than a book about physics. It's a meditation on existence itself, on how the universe began, how it works, and what our place within it might mean.